So cache eviction is another important part of caching. What does it mean? Eviction is nothing but removing the items from cache to provide some space for newer items that are getting in. For example, cache, suppose there is a cache available of capacity 2 GB. Just giving an example. And you are feeding more and more information to cache, and the cache has become full. And then now you have to store a new information to the cache. Then the question is what to remove, what should go out of cache, and how the space will be available for the newer item. Sometime I'm just mentioning here, I'm not mentioned in any of this diagram, but sometime what we do that when we do a calculation that, okay, by looking at the kind of user request that we are going to get, what kind of traffic that we are going to get, and what kind of information that we would like to cache, that calculation will decide, okay, I need a storage of suppose 2.5 GB. I'm just giving an example. So in that case, what we do is we usually keep that some extra space in cache itself. Like we will not keep the cache memory exactly 2.5 GB, but we will keep the cache memory maybe 3 GB or maybe more than that. Why? Because that is our assumption that we will get a certain kind of traffic, certain kind of data need to be in cache. So that is something our understanding. But it may possible that certain time that the requirement will be more than what we expected. So in that case, just to have that buffer, keep that buffer to serve the user when the user base or user requests are more than that is expected. So we also keep the cache memory an extra space, not what is expected, but more than that. So that is one strategy is there. But what if the cache still get full? Still it is filled fully, the whatever capacity, whether it is 2 GB or 3 GB. So in that case, we have to decide that, okay, what should go out of the cache? What should we remove from cache? So cache is itself is a layer which we usually, the main purpose of is has to store the information and so that user can access it quickly. That is the main purpose of cache. But we have to decide that if what we have to do if the cache is full, how we should make space for the newer items to get into it, into the cache. So there are these strategies that I mentioned here. So let's look at one by one. See, some of them are very clear, very easy to understand, so you don't have to worry about. I'm just going to give an explanation that what exactly we are going to look at. So first strategy is LRU. What LRU means, least recently used, where we will remove the cache item, cache data, which is least recently used. Least recently used means if you look at this diagram, we have fed in some data. Okay, these green dots are some data out of which we are looking at the, okay, for each of these data or cache items, what is the time that it is being used, like when we have used last time. Here I mentioned time elapsed since last use. So since last I have used, how much time it is gone. Like I've used 5 minutes ago, 10 hours ago, 5 hours ago. So these are some of the examples that this particular data has been used 5 minutes back. So it is recently used. Then 15 seconds, this is most recently used. So these kind of information that we kept that has to be tracked by cache itself. There will be some mechanism that we'll use to track that information that when we have used this particular cache data. And then looking at this information, it will look at, okay, the data number 2, which I mentioned here in orange color, which is used 10 hours back. So that means it is a lot of time has gone since we have used it. That means it is not least come under the least recently used. So this kind of data will get removed. Okay, least recently used means which is not used since some time. Time may be 10 hours, time may be 5 hours, but out of all the caching data, we'll just look at the which one has is sitting there in the cache for longer time and it is not being used. So we'll look at that information and that information will be removed from the cache itself. Because this strategy you have to choose when we are designing the system, when you're deciding what to cache, that time you have to do these kind of setting in your cloud machine where the cache itself will take care of what to remove. But you have to decide on which strategy that you are going to use. And that will be taken care by a cloud provider where you have to just do kind of setting that I want to use LRU method to you for the cache eviction. Okay. And here I have given some description that this approach is based on the item that are least recently accessed. Okay. So that will go out because the idea behind is because this has taken 10 hours and user has not used it, it means this information, there are chances that this information is not needed for user. User is not accessing this information more frequently. And second, this is information also maybe uh, not the latest one because 10 hours are gone. You just imagine within 10 hours, maybe the information got updated. So that needs to go out so that if it is requested by user, we can again cache it later on, but with the latest information. So that chances will be here. So here, what we are looking at, we are removing the information that is being not used more recently. That means least recently used. You just have to understand what is the meaning of this word. Least recently used means it is not used more recently. Okay. Next strategy that we are looking at is most recently used. Okay. There is a typo here. It's MRU. Most recently used. What does most recently use is the item that is most recently used that will get removed. Now you will say, oh, what kind of strategy is this? But there are depend on system to system. This strategy changes. It's about your system or the situation that you are, for which you are going to do this kind of caching. That will be decide that okay, what kind of strategy that you have to use. So as per this algorithm, most recently used items will get removed, and these are scenarios where you think that this item, whatever most recently item, we don't need it, so that will get removed. See, this is also uh, applicable. Like there is something called LIFO FIFO. Do you think with which it will get uh, applicable? Like out of LIFO and FIFO, there are
LIFO, I
one of the
think.
strategy will get linked with this. Do you know which one?
I think LIFO,
Are you sure?
last in, first out. Least recently, right?
Okay.
Sorry,
See,
most recently, right?
yeah, yes. So there are the FIFO we are going to discuss, but as you mentioned, LIFO is the one because LIFO will be last in, right? That will be latest one. Okay, and that will go out. So that is applicable. So maybe because I'm mentioning right now itself because there are chances people may ask because we are going to look at FIFO, that is first in, first out. LIFO is last in, last out. Oh, sorry, last in, first out. So that is applicable here. This is the same one, most recently used. That is which is with last that came in that we are going to remove out. So that strategy we are going to use. And the chances of most of the time, again, it depends on situation or system where you have to decide on, okay, whatever latest that is going to come or most recently that is being used, that will go out. Most recently used, again, I'm mentioning. So here, again, in this diagram, most recently is 15-second one, which is the most recent one that is being used, and that will go out. Okay, I hope these concepts are clear because you just have to look at the name and decide on that. Okay, least recently used, most recently used, and least frequently used. Again, see these terms you have to keep your mind straight that these terms you need to understand, then you will easily understand the concept. Okay, so least frequently used is we are looking at the frequency of time the user access that particular data or cached item. So here we are not looking at the time itself, like how much time it lapsed, but how many times it has been used. So what is the frequency of that? So looking at this particular diagram, There are something that is used 200 times, 100 times been accessed by user, 5 times, 20 times. So out of which we look at, okay, 5 times is very less time it has been used. It's the frequency is very less. User has just accessed 5 times, not 20 times or 80 times. So what we'll do, we'll remove that item from the cache. Okay. Is here we are going to look at least frequently used. That is the frequency that we are going to look at. What is the lowest frequency out of whichever item that has been accessed by user. All right. So these are some of these strategies. Let's move ahead with the other one. But so far, do we have any question on this? No. Let's move ahead then. Okay. There are more strategies like this one. Right now, we are looking at last in, first out, LIFO. We have seen in most recently used, but FIFO is also there, first in, first out. This is the simplest one. It's look like a queue to us. Okay, whatever goes in first, that will go out first. Okay, so this is the simplest strategy. As I have numbered this, that you will first will go the first one, the second one, the third one, and whenever we have to remove it, it will get removed in the same queue. We'll enqueue this the similar way. The NQ1, and then it will get out of this cache in a sequential manner. Okay, so whatever oldest item is there in the cache, it will just get removed from the cache itself. And you don't have in this kind of strategy, see from above strategies, we have to keep track of what how much time that it spent in the cache itself, whether it is time, whether it is frequency. But you have to keep tracking that. Okay. But these kind of strategies, especially first in, first out, you don't have to track that information. You don't have to worry about how much time it spent or what was the frequency of it and all those things. It is the simplest one. Whatever will go first in will go out first. Okay. This is the simplest one. And there is something which is most of the time being used. It's called TTL, time to live. This is again a setting in on your cloud provider where in this kind of strategy, when you add any particular data in your cache, that time you specify the time where in how much minutes or how many hours or whatever time that you give along with the TTL, like time to live, till that time the data will be available. Maybe if I'm giving it for uh, half an hour, suppose I'm just giving, or 1 hour, 60 minutes. If I'm till the 60-minute time is not finished, when 60-minute will start, once you add that data to the cache, with that you will also give the uh, TTL value, time to live value, that is 60 minutes. And until and unless, since the data is added, 60 minutes is not over, that data will not get removed. So again, what kind of time that we need, how much time we need to keep that rate depends on again situation to situation and system to system. It is you who have to decide on that. That what will be the best time, suitable time for that data to live in cache, or it will not get updated. So that is how you usually give this information when we actually store the data into the cache. Okay, so more this is nowadays this is mostly used, but again, you have to see to it that which strategy is applicable to your system. You have to specify the time itself. Maybe I don't know whether you have seen the Redis or Memcache code where it is the simplest key value store where also you have to provide TTL value where you can specify, okay, I want to store the data for 5 minutes or 50 minutes or 60 minutes. And after that, it gets removed automatically. You don't have to worry about to getting this information out. It will get automatically removed and the space will be available immediately. Okay, so that is one strategy, time to live. And there is last one, which is the most easier one, is random replacement. What this will do, that it will be randomly pick any data from the cache and it will remove it. Okay. Here again, it's simple to implement, and as well as you don't need to have tracking of all the information. See, even time to live, you don't have to track, even though I mentioned the time here, but that is, you don't have to worry about it. The cache itself will take care of that. The Redis kind of in-memory database, they will take care of itself. They will automatically remove this data in time to live. In the random, again, there's no need of uh, any of the tracking purpose. Here, we are just removing any information randomly from the data memory itself. But there are chances that the required information or most recently or something that is more frequently accessed by user that may get removed. Then you have to go back to database, get that information, store back in cache. That repetition will increase. So it may increase some kind of latency, but it depends on situations to situation. Okay, but you don't have to worry about all kind of tracking of time and as well as frequency. Okay, so these are all, again, I'm mentioning these are all strategies had to be decided while we design a system, what kind of strategy that we are going to use. And these are an important aspects of cache. Okay, I also mentioned about uh, cache at what different places of cache that we use, whether it is load balancer or whether it is separate distributed cache. But cache is something that is help to make user uh, access the information as quickly as possible, because that is what the idea behind system. Just imagine if you are sending an WhatsApp message to someone, and if that message taking time 5 minutes, it's too much. So what we are trying to do is messaging is something like uh, still real time. You are typing because that information you cannot cache. But okay, later on after maybe few days, you're trying to access the same information from someone has sent a message to you. So that information should be quickly available to you. You should be able to access that messages that is you have communicated in past with someone. So that information should be accessed immediately. Maybe it is reading from database, maybe it is reading from cache. But at any place, the cache is mainly to give a quicker response. See, I'm not getting into depth now. Later on, if we need any more information, we will definitely look at it. And there are, see, these are not the only strategies. There are more strategies also available for eviction. There are custom strategies also available. There are more other strategy also available. If you search internet, you will get something different, something new. But these are the mostly used one. So that's why I would like to mention this to you. Okay, so I'll not go ahead. I'll stop recording now.